In 1991, two hikers trekking through the Italian Alps made a discovery that would change our understanding of ancient history. They stumbled upon a frozen body, perfectly preserved in the ice for over 5,000 years. Little did they know, they had just found one of the most significant and captivating archaeological treasures of all time. Otzi the Iceman. Ötzi was a man who walked the earth during the Copper Age, around 3,300 BC. He was approximately 45 years old when his life was cut short, but what a life it must have been. He was a resilient hunter, navigating the treacherous alpine landscape armed with a revolutionary copper axe, a longbow, and a distinctive bearskin hat. His body was a canvas of ancient art, adorned with dozens of tattoos, and a medical chart of its time, showing evidence of various ailments and injuries he endured. His end was not peaceful. It was violent. An arrowhead, lodged deep in his left shoulder, severed a major artery, causing him to bleed to death in the cold, unforgiving mountains. But how can we possibly know such intimate details about a man who lived millennia ago? The answer lies in a molecule so small it's invisible to the naked eye, yet so powerful it contains the blueprint of life itself: DNA. Ever since his discovery, scientists have been meticulously studying Otzi's DNA, peeling back the layers of time to uncover the secrets of his existence. Now, a groundbreaking new study has used state-of-the-art technology to sequence Otzi's entire genome, his complete genetic code. The researchers compared his DNA to that of both ancient and modern populations, allowing them to reconstruct his origins, his true appearance, and his genetic predispositions with unprecedented accuracy. The results were shocking, and in this video, we will explore the incredible new revelations from Otzi's DNA that are rewriting his story. The most astonishing finding from the new analysis concerns Otzi's ancestry. Previous studies suggested he had a significant genetic link to steppe herders from Eastern Europe. However, this latest research paints a very different picture. It turns out that a staggering 92% of Otzi's ancestry traces back to early Anatolian farmers, who migrated from present-day Turkey and brought agriculture to Europe. The remaining 8% of his genetic makeup came from European hunter-gatherers, with almost no trace of the steppe herder genes that would become common in the region a few centuries after his death. This suggests that Otzi belonged to a surprisingly isolated community in the Alps, one that had very little contact or interbreeding with other European groups. In a fascinating twist, the analysis revealed that his closest living genetic relatives today are not found in mainland Europe, but on the island of Sardinia, where the population has retained a high proportion of Anatolian farmer ancestry. Perhaps even more startling was the revelation of Otzi's true physical appearance. For decades, reconstructions have depicted him with light skin, long shaggy hair, and a weathered leathery complexion. The newfound evidence shatters this image. Genetically, Otzi had a much darker skin tone than the average modern-day European, a feature more common among his Anatolian farming ancestors. His eyes were not blue, but a deep brown or hazel. And his full head of hair? That was also a misconception. The analysis identified genetic markers strongly associated with male pattern baldness, indicating that he likely had very little hair on his head by the time he reached his mid-40s. The light-skinned, hairy mummy we see today is not how Otzi looked in life. Its appearance is the result of thousands of years of mummification in the glacier, a process that chemically altered his skin and preserved the hair that had fallen from his head. Beyond his appearance, Otzi's genome provides a detailed medical report from the Copper Age. He was a genetic ticking time bomb for several modern ailments. His DNA carried a high predisposition for obesity and type 2 diabetes, conditions we often associate with contemporary lifestyles. He also had genetic risk factors for heart disease, arthritis, and stomach problems, including ulcers caused by the H. pylori bacterium. Scientists even found evidence of gallstones and confirmed he was lactose intolerant, meaning he couldn't digest dairy. His body was also a host to other unwelcome guests. Analysis of his intestines confirmed the presence of parasites including whipworms. His DNA even carried markers for Lyme disease, making him the earliest known human case of the tick-borne illness. This genetic profile offers a powerful reminder that many of the diseases we face today have deep ancestral roots. While his genes foretold a future of potential health issues, it was immediate, physical trauma that ultimately defined the end of Otzi's life. His mummified body is a chronicle of violence and hardship. A deep, unhealed cut on his right hand, slicing down to the bone, suggests he was involved in a fierce hand-to-hand struggle shortly before his death, likely fending off an attacker with a knife or axe. He had also sustained injuries to his ribs and skull from blunt force trauma, indicating he was likely beaten. But the final fatal blow was the flint arrowhead fired into his back. It pierced his left shoulder, tearing through his subclavian artery and causing catastrophic internal bleeding. He would have died within minutes, alone on the frozen mountain. This evidence of a violent end only deepens the mystery of his death. Who was Ötzi fleeing from, and why was he killed? The circumstances remain a subject of intense debate among archaeologists. Was he a hunter caught in a territorial dispute with a rival group? Was he a tribal leader ambushed in a power struggle? Perhaps the attack was the result of a personal feud that escalated to a deadly confrontation. Some have even theorized that his death was part of a ritual sacrifice. The last meal found in his stomach was dried ibex and deer meat, einkorn wheat, and toxic fern was consumed shortly before he was shot, suggesting he was not expecting an attack. The motive and the identity of his killer remain an unsolved murder mystery, frozen in time. The dramatic difference between Ötzi's genetic profile and his mummified appearance highlights the transformative power of the glacier. For over 5,300 years, the ice acted as a natural time capsule, but it also fundamentally altered his body. The extreme cold and pressure changed his skin's pigmentation, making it appear darker and more leathery than it was in life. The preservation process also affected his hair, making it seem as though he had a full head of it, when in reality, his genetics point to advanced baldness. This distinction is crucial. It reminds us that while a mummy can preserve a body, only DNA can truly resurrect the appearance of a living, breathing person from the deep past. Ultimately, Otzi the Iceman is more than just a remarkably preserved mummy. He is a direct link to a lost world. He provides a unique, high-definition snapshot of a single individual from the Copper Age, allowing us to understand what people wore, what they ate, the tools they used, and the health problems they faced. His preserved body has opened a new chapter in the story of human migration, showing how ancient populations moved and mixed across Europe. As our technology for genetic analysis continues to advance, Otzi's genome will undoubtedly reveal even more secrets, offering fresh insights into our shared human story. He is the gift that keeps on giving, a 5,000-year-old man whose secrets are still being unlocked, one sequence at a time. Thank you for watching. If you enjoyed this video, make sure to leave a like and subscribe to support the channel.